Hello everyone, I'm Ziad Malim from SOMA Academy, and today I'm going to show you how to find the derivative of a function using the chain rule. We normally use the chain rule when we have a composite function. What a composite function means is that you have a function inside another function, similar to what we have here, f of g of x, where f of g of x is the outside function and g of x alone, g of x is the inside function. Okay, let's do an example. Say we have a function 2x squared minus 3x to the power of 5, and we want to find the derivative of this, d of dx. Okay, in order to find the derivative of this function, f prime of g of x is equal to, the general formula is you find the derivative of the outer function keeping the inner function the same and then multiplying with the derivative of the inner function. So this is the general formula for the chain rule. The chain rule is such that you take the derivative of the outside function keeping the inner function the same and then multiplying with the derivative of the inner function. Okay, let's do this example we have here. We have 2x squared minus 3x to the power of 5, and we want to find the derivative of this. In this case, what we have to do is bring the power down, that 5, bring it down, keep whatever is inside the bracket the same, 3x, reduce the power by 1, so 5 minus 1 is 4, multiplied by the derivative of whatever inside. So the derivative of 2x squared minus 3x is, bring the power down, 2 times 2 is 4, reduce the power by 1, 2 minus 1 is 1, minus the derivative of negative 3x. That just gives you the constant, because the derivative of negative 3x is, bring the power is 1 times 3 is just 3, so when you reduce 1 minus 1, that is 0. Any number to the power of 0 is 1, so that's why you have that. Okay, so let's just clean this up. So you can say 5 multiplied by 4x minus 3 multiplied by 2x squared minus 3x to the power of 4. You can expand this, but you can also leave it this way. So in general, the formula is such that you use a combination of the power rule, but keeping in mind this formula here. You first take the derivative of the outer function, keep whatever is inside the bracket the same, multiplied by the derivative of the inner function. Okay, let's do one more example to make this very clear. Say for example you have this 5x plus 3 to the power of 7, and you want to find the derivative of that, okay, of all this. So the formula is take the derivative of the outer function. So in that case we use the power rule, which I have explained in another video that I will link in the description below. So bring the power down, 7, keep whatever is inside the bracket the same, 5x plus 3, reduce the top power by 1, 7 minus 1 is 6, multiplied by the derivative of the inner function. The derivative of the inner function, which is the derivative of, let me just write down, the derivative of 5x plus 3. What will that give me? When you take the derivative of 5x plus 3, that just gives me 5, because the derivative of a constant is always 0. Okay, so what I have here is 7, whatever is inside the bracket, 5x plus 3, the power has already been reduced, times 5. So you can multiply this 5 with 7, which will give you 35 5x plus 3 to the power of 6. So this will be your final answer. Okay, let me do one more example which is similar to this. So find the derivative of say 2x cubed plus 4 to the power of 6. Okay, in order to find this, we said take the derivative, bring the power down, 6, keep whatever is inside the bracket the same. Okay, reduce the power by 1, 6 minus 1 is 5, multiplied by the derivative of whatever is inside the bracket. So the derivative of this will be, use the power rule, 6, why is 6? Because it's 3 times 2 is 6, x to the power of, reduce the power by 1, so x squared. The constant just becomes 0, because the derivative of any constant is 0. Okay, so from there you can simplify this further. 6x squared times 6, that is 36x squared, and then 2x cubed plus 4 to the power of 5, and that is your final answer. Okay, let's do another example. Let's do another example. Okay, say you want to find the derivative of sine of 7x. You want to find the derivative of this. Okay, same thing. The derivative of sine, that is cos of whatever is inside the bracket, keep it the way it is, multiplied by, what is the derivative of 7x? The derivative of 7x is just 7. Okay, so this will give me 7 cos of 7x. Okay, let's do another example. Let's find the derivative of cos 4x squared. The same thing. First thing is you have to find the derivative of cos. What that is equal to negative sine, keep whatever is inside the bracket the same, 4x squared, multiplied by the derivative of what is inside the bracket. The derivative of 4x squared is 8x. Okay, it is 2 times 4, reduce the power by 1, that becomes just 1. So this will be minus 8x sine of 4x squared. Okay, let's do one final example where we have to use the chain rule. Okay, say you want to find the derivative of tan x squared. It is the same rule. Find the derivative of the outer function and then multiply with the derivative of the inner function. So the derivative of tan is secant squared. Keep whatever is inside the bracket the same, multiplied by the derivative of whatever inside the bracket. x squared, the derivative of x squared is 2x. Therefore, the answer is 2x secant squared x squared. And that is the answer to this problem. I'll stop it there for today. I hope this was helpful. Please do not forget to subscribe and give this video a like. Until then, happy learning.